Nerdinas! Today, I am back with another video. We are going to be talking about routers. If you look at my previous video, we discussed what exactly a router is. In this video, we are going to be talking about configuring a router. Just to review, routers are information gateways, meaning that routers route all information to and from the internet to computers on a local area network. Routers have multiple functions. The first, as we just discussed, is an information gateway. In addition, most routers also have security features, and these security features defend against hackers trying to access all internet-connected devices within a local area network. In addition, the security features on a router control when and how computers outside the network can connect to computers inside the network. This means that, for example, you need a password to connect to a network. Lastly, the security also controls how a network appears to the outside world. One of the main jobs of routers is assigning IP addresses. IP addresses are assigned using what is called DHCP, or Dynamic Host Configuration Protocol. Routers are automatically able to create IP addresses and assign them to devices on the local area network. Over here, I've logged on to my home router's main interface simply by entering the LAN IP address of my router and logging in. Now we can see how exactly the DHCP assigns IP addresses. IP addresses are assigned in order. So as you can see, the first assigned IP address is for my iPhone. And this IP address is 192.168.1.3. So as new devices connect to the router's network, the next available IP address is assigned. So here you can see 1.3 and then 1.4, and there's probably another IP address, 1.5. But there are two types of IP addresses. This IP address is dynamic, meaning that if you were to connect onto another network and reconnect back onto this network, the IP address would change. So for example, Aruna Prasad's iPhone, the IP address ending in 1.3, is not permanent. However, if you don't have a DHCP, it means that you manually assign one static IP address. So for example, you can see here that this device does not have a dynamic IP address, and instead it is static. So the default for any IP address is that DHCP is enabled. However, if you want, you can also manually assign an IP address to a device. Routers assign IP addresses in order, as we just discussed. And seeing that the first IP address was 192.168.1.3, there are definitely not enough devices for the router to get all the way to the ending 153, which is how I know that this address is static. The default for any IP address is that DHCP is enabled. However, if you want, you can also manually assign an IP address to a device. To assign a static IP address to a device, you can go to System Preferences and then click Network. Here, if you go to Advanced and then TCP/IP, you can see that we are currently using DHCP with a dynamic address, meaning that the computer automatically assigns an IP address to a device. Alternately, you can also use DHCP with a manual address, meaning that over here you can enter any IPv4 address. Now it's time to talk about the physical connections on a router and actually show you all what a router looks like. As we discussed in our last video, in order to connect to the internet, a router has a place to plug in an Ethernet cable. which is a cable shared by all devices on a network, and a path for electronic signals to travel on. The Ethernet cable is connected to what is called a modem, or a modulator-demodulator, which enables a computer to transmit data. There are two different types of networks, a local area network and a wide area network. And on our router, we have places to connect both. So just a quick review, a local area network is a network within a house or an office building, typically. And the IP addresses on a local area network are unique only to that one network. A wide area network is a combination of two or more local area networks, and it spans a much greater area. An IP address on the wide area network is unique worldwide. In fact, the internet is a wide area network. There are two different types of IP addresses, IPv4 and IPv6. IPv6 is a longer IP address than IPv4 to accommodate the increasing number of devices. If you want to learn more about these two formats, you can go look at my last series on how the internet works. I will link that below. This right here is what a typical home router looks like. So let's talk about the physical connections on this router. As you can see, right here, I've already plugged in the power. Our next connection is for the internet. The internet, as we said before, is a wide area network. And this, right over here, is an Ethernet cable. I'm just going to plug this in now. The Ethernet cable connects to a modem, which we just talked about. Now, these four right here are also connections that need Ethernet cable. These are LAN connections, and they connect directly to desktop PCs and other devices. Now, let's talk a little bit more about IP addresses. So, as I mentioned before, every router has a LAN IP address and a WAN IP address. So the LAN IP address of our router, as you can see right up here in the address bar, is 192.168.1.1. And here you can see the corresponding WAN IP address. Similarly, for any device, you can find both the LAN IP address and the WAN IP address. Once again, the LAN IP address can be seen through a home or office building network, while the WAN IP address can be seen anywhere on the internet. Let's test out the LAN IP address and the WAN IP address for my computer. So my computer is this one right here, and we can see that my LAN IP address is 192.168.1.4. Now, using a website called whatismyip.com, which is just loading now, we can also see my WAN IP address right there. It is important to note that the IP address being shown here is my router's WAN IP address that is being used to connect to the internet. As we saw before on the router itself, there are 4 ports where you can physically connect devices. However, today we don't physically connect all of our devices to a router. Instead, we have what we commonly call Wi-Fi. Wi-Fi is a wireless local area network technology, and it provides internet and connections to a network using radio waves. And as I said before, this means that you don't need to directly connect all of your devices to a router. Using Wi-Fi, radio frequency current is supplied to an antenna, and this creates an electromagnetic field that spreads through space. Let's talk a little bit about Wi-Fi security. Wi-Fi is less secure, obviously, than connecting a device straight to your router, because any device on a network can access Wi-Fi. And therefore, we have a couple of different types of protection. The first type of protection for a Wi-Fi network is WEP, or Wired Equivalent Privacy. WEP was built to ensure that data confidentiality is comparable to a traditional wired network. The second type of Wi-Fi security that is commonly used is WPA, or Wireless Protected Access. This is an upgrade from WEP, and it is a security protocol that is both stronger than WEP and also addresses the weaknesses that were found in the wired equivalent privacy security. And WPA uses what is called encryption to keep our data safe. Don't worry if you don't know what encryption is yet. I'll be doing a whole video explaining how exactly encryption works and also what it is. Over here, I am back in my router's main console, and you can see that we have different types of Wi-Fi security. As I mentioned before, there's both WEP and WPA. My network is using WPA because, as we mentioned just before, it is the strongest type of security. And WPA is actually just the password to access a network, which keeps it secure. As we discussed before, routers send and receive packets of information to and from the internet. We can see over here that the router interface keeps track of how many packets have been received and sent by the router. Next, let's talk about some additional useful features on a router. A router can do what is called port forwarding, which is allowing access to devices traditionally on the local area network from the wide area network. For example, we can give access to a particular device through a port. Think about a security camera that is on a local area network, but you want to access it from outside of your home network. Essentially, port forwarding allows information from one device to be forwarded to another device. As you can see on this list, a variety of devices have been forwarded using different ports. What if we want to make sure that a device is properly connected to a network? Or we want to identify the local area network IP address of the device we are currently using. We can do this without even logging into our router's interface, and here's how. We can use two commands commonly called ipconfig and ping. ipconfig allows you to find the IP address of a client device. In this case, we'll be finding the IP address of the device I'm currently using. Ping is a command that allows you to check to see if a device is connected to the web. This is done by sending packets of data to the device and seeing if there is a response. Here you can see the specific commands that I will be using. I am now opening up the terminal and typing in the ipconfig command. Using the command above, which is specifically for a Mac, ipconfig get if adder en0. On a Windows computer, this would be a lot simpler, just ipconfig. We can get the IP address of the computer I am currently using, which is 192.168.1.4. And you might remember that we also saw this IP address through our router's main administrative page. To see, for example, whether my computer is connected to the internet, we are now going to use the ping command. So as I just said, the IP address of my computer on the LAN network is 192.168.1.4. Now now you can see that has been sent, 56 data bytes have been sent to my computer. And here you can see that there is a response, meaning that my computer is connected to the internet. And this response will keep coming in, so I'm just going to cut this. But these two commands are probably some of the most useful because it tells you the IP address of the device you're on and also whether any device on your network is connected to the internet. As we discussed before, IP addresses are continuously changing unless they're static. DDNS or dynDNS stand for Dynamic Domain Name System. As we mentioned before, many IP addresses are dynamic, meaning that they are continuously changing. We can use dynDNS to track dynamic IP addresses. So if I were to purchase a service such as dynDNS, I would be given a static address. For example, arunahome.dynDNS.org. I don't actually have this service, but this is just an example I came up with. Whenever I typed in this address in my computer, it would automatically route to whatever my current IP address is. Now you have a basic understanding of routers. From our last videos, you can see what a router's job is and how it works. And in this video, you got to learn about specific features on a router, as well as configuring a router and the physical connections that are needed. I hope you learned a lot, and I'll see you in our next video. From each Nerdina to all Nerdinas, adios.